Welcome back to Cosmic Compass, the channel where we explore the mysteries of space planets and the cosmic phenomena shaping our universe. Today, let's journey together to a small rocky world far from Earth, an asteroid called Bennu. For the past year, NASA's OSIRIS-REx spacecraft has been circling this tiny body, uncovering secrets scientists never expected. What has it revealed, and what challenges remain? Let's dive in. Imagine a spacecraft circling a mountain-sized rock in deep space. Not a planet, not even a moon, but a lonely asteroid only half a kilometre wide. This is Bennu, and for over a year NASA's OSIRIS-REx mission has been orbiting it at just a few hundred metres above the surface. Never before has a spacecraft orbited such a tiny body. Being so close has allowed scientists to map every contour, every rock in stunning detail. So what has OSIRIS-REx found so far, and what challenges still lie ahead? Bennu is incredibly small, only about 500 metres across. With such a low mass, its gravity is barely noticeable. If you tried to jump, you might escape it entirely. That means one orbit around Bennu takes an astonishing 62 hours, even when flying just 1.75 kilometres above the surface. Yet orbiting was essential. By circling the asteroid while it rotated beneath OSIRIS-REx, could piece together the most detailed surface map of any celestial body ever created. Why? Because this mission is not only about observation, it's about collection. OSIRIS-REx was designed to retrieve at least 60 grams of material from Bennu's surface and return it safely to Earth. While we already have thousands of meteorites here on the ground, they are altered by atmospheric entry, heated to scorching temperatures, and contaminated by Earth's environment. A pristine sample sealed in space offers something meteorites never can: an untouched record of the asteroid's original chemistry. With such a sample, scientists hope to uncover organic compounds like amino acids, hydrated minerals such as clays, and perhaps even clues about the raw materials that help spark life itself. Let's see what the spacecraft has already revealed. OSIRIS-REx is more than just a camera floating in space. While it has captured thousands of detailed images, it has also conducted spectroscopic surveys, scanning the chemistry, mineralogy, and global properties of Bennu. This gives scientists the context they need to interpret the samples once they are returned to Earth, and almost immediately the spacecraft found something remarkable. Hidden in Bennu's dark surface are hydrated minerals, specifically clays. Now, this may sound ordinary, but clays are a direct sign of water. A body as small as Bennu could never have held liquid water on its own. The gravity is simply too weak. So what does this mean? It means Bennu likely broke off from a much larger parent body that once contained liquid water. Over billions of years, fragments of that ancient world drifted through space until they became the rubble pile we now call Bennu. This discovery is significant because it pushes us closer to understanding how water and potentially life's building blocks might have been delivered to Earth. The presence of hydrated minerals suggests Bennu once carried traces of the same ingredients that shaped our planet's early chemistry, and soon OSIRIS-REx will bring those ingredients back to us. But while the presence of clays surprised scientists, Bennu's surface itself delivered an even bigger shock. Before OSIRIS-REx arrived, ground-based radar images painted Bennu as a relatively smooth-rounded asteroid. But when the spacecraft finally came close, it revealed something very different: a chaotic, rugged world covered with enormous boulders. The largest of these towers, over 20 metres high, about the height of a 6-storey building, and spreads across an area as wide as a football field. Other boulders are the size of cars, horses, or even entire houses. Everywhere the cameras looked, the surface was littered with debris. For scientists, this was a serious problem. The mission's sampling arm was designed to land on an area about 25 metres wide, filled with particles no larger than a centimetre. Essentially, OSIRIS-REx needed to find a cosmic sandbox in the middle of a jagged mountain range. Eventually, 4 potential sites were identified: Osprey, Kingfisher Nightingale, and Sandpiper. Each was small, no larger than a parking lot, but relatively free of hazards. Even so, navigating to them will be a monumental challenge. Imagine trying to land a spacecraft with pinpoint precision on a spot the size of a few car spaces while orbiting an asteroid that barely holds onto its own rocks. Any miscalculation, any drift toward a nearby boulder could mean disaster. Still, the mission team refined their plans, adjusting trajectory models and testing backup options. Soon, they will attempt the daring maneuver that could make or break the entire mission. For all the surprises Bennu had offered already, one of the most unexpected was that it wasn't entirely still. OSIRIS-REx observed sudden ejection events, moments when small particles were flung from the surface into space. Some of these grains even lingered in temporary orbits before falling back down. Why would a rubble pile asteroid behave this way? The answer lies in Bennu's rapid rotation, and here's the twist: its spin is actually increasing. This gradual acceleration comes from a subtle force known as the Yorp effect. As sunlight strikes Bennu's irregular surface, it pushes ever so slightly, altering its rotation over long timescales. Already, this spin has reshaped the asteroid. Along its equator, rocks have piled up from centrifugal force, forming a ridge around its middle. If the spin continues to increase, Bennu could eventually reach a breaking point. The weak gravity that holds it together may no longer be enough, and the asteroid might begin to shed material or even tear itself apart. This realization transformed our understanding of Bennu. Far from being a static, lifeless body, it is dynamic, evolving, and potentially unstable. Watching this process unfold gives us rare insight into the life cycle of small bodies in our solar system and a hint of how fragile they truly are. So what have we learned? Bennu is far from the smooth asteroid scientists once imagined. Its surface is rugged, covered in boulders the size of houses. It carries hydrated clays, pointing to an ancient connection with water. And it isn't silent, it is active, spinning faster with time, sometimes hurling particles into space. Yet the most important part of the mission still lies ahead. OSIRIS-REx must descend to Bennu's surface, touch down on one of those small safe zones and collect a sample. If successful, that material will be sealed and brought back to Earth. And inside, perhaps, are the answers to questions we have asked for centuries. Where did Earth's water come from? Did asteroids like Bennu help deliver the building blocks of life? Soon, we may hold those answers in our hands. Until then, Bennu continues to surprise us, reminding us that even the smallest worlds can reshape our view of the cosmos. That was our journey to Bennu with OSIRIS-REx, a mission rewriting what we thought we knew about asteroids. If you enjoyed exploring with us, don't forget to subscribe to Cosmic Compass for more stories from across the universe. What discovery surprised you the most? Water hidden in clay's giant boulders, or Bennu's strange activity? Share your thoughts in the comments below. Until next time, keep looking up, because the cosmos always has more to show us.